Good day, ma'am. I am Angelica Salingay from BS and TREP 1A. So I'm going to discuss the cell patterns observed in our skin, leaves, and animals' fur. So this is related to us in our real life because we have a skin which have a pattern of tessellation and Voronoi diagrams. So the tessellations are like a honeycomb or other pattern that are the same shape. These are arrangement of shapes that completely cover a surface without any gaps or overlaps, which our skin has. And then, in the case of skin leaves and furs, cell or scales forms tessellating patterns that maximizes coverage while minimizing wasted space. This efficient packing is a result of evolutionary pressure to optimize functions like protection, moisture retention, or light absorption from bacteria or anything that will come inside our skin or the animal's skin or the leaf's skin that affects its texture. And then the second one is the Voronoi diagram. So the Voronoi diagram is a partition of space based on the distance to a set of points. In biological context, these points represent cell nuclei or other structural features. The areas of influence around each point define the boundaries between neighboring cells in skin. These boundaries help maintain structural integrity and facilitate functions like sensation or health regulation. So, Voronoi diagrams is relating to us to its shape in our skin because our skin has the same pattern as the Voronoi diagram, which is the explanation of a mathematical formation. These mathematical patterns emerge as a result of optimization processes driven by biological and environmental constraints. They demonstrate how nature utilizes mathematical principles to achieve functional and aesthetic outcomes in living organisms. So the cell patterns in skin, leaves, and animal fur serves various purposes in our life or real life. In skin cell patterns, it contributes to structural integrity, elasticity, and protection against external factors. While in leaves, cell patterns facilitate photosynthesis, water absorption, and gas exchange. While lastly in animal fur, cell patterns provide insulation, camouflage, and protection from predator, which from a mathematical perspective, these cell patterns exhibit complex spatial arrangement and symmetries. Mathematics helps describe and understand these patterns through concepts such as tessellation, fractals, and symmetry transformation. Like for example, the Voronoi tessellation model, which can describe the irregular cell shape found in skin patterns, which is our skins, while fractal geometry can explain the self-similar branching patterns in leaf veins. Understanding these mathematical properties not only deepens our comprehension of biological systems but also inspires the development of mathematical models for various applications such as graphics and pattern recognition algorithms. So there are several things that are inspired by cell patterns found in our skin, leaves, and animal fur due to their efficiency, robustness, and aesthetic appeals. So the examples are the textile designs, and there are others and many more like the urban planning, product design, computer graphics. But for in summary, the mathematical principle underlying cellular patterns in skin, leaves, and animal fur inspired by the various fields ranging from design and architecture to urban planning and computer graphics. These principles include geometric optimization, fractal geometry, Voronoi diagrams, and cellular automata, among others. By harnessing this mathematical concept, designers and engineers can create innovative solutions that are not only efficient and functional but also aesthetically pleasing to everyone's eyes, which we all people can relate that we want like this pattern because we want aesthetic, because we want to be fit in the trend, and the trend is found in these various patterns. And that's all for my discussion. Thank you.